All right, welcome back to the second lesson in Unit 5. We are going to be looking at composite function today. Um, Before we do, let's talk about what we did last time. We were combining functions last time, and that means we were adding, subtracting, multiplying, and dividing functions, right? So today we're gonna be looking at a composite function, and let's look at the definition first, and then I'll show you what it is. Okay. So here it is. Here it is. It says suppose that f and g are two functions. The composition f of g, okay, this is what we call f of g, is defined by. So here's the definition. Here's the notation. Okay, f is a circle. Okay, but it's called f of g of x, and that's the same thing as this f, and then bracket g of x, and close the bracket, and we read this as f of g of x. So again, this is the notation, but I think this might make more sense to you because this is like looks kind of random. It's f circle g. You might think does that mean it's f times g? Okay, it's not, right? It's a circle, not a dot. Anyways, that's what this composite function is. Basically, what you have is you have an inside function, that's g of x, and this inside function is being put into the outside function, which is f of x. Okay, so you have the inside function g of x, and you have the outer function f of x. Okay, so you put g into f. That's basically what it is. Okay, so I'll show you some examples here, and then it's actually not too difficult. Okay, I'll show you. Okay, so let's say f of x is equal to 2x plus 3, and that g of x is equal to x squared. It says, what is f of g of x? Okay, so again, this means f of g of x. Okay, that's what that means, which means we're going to put g of x, okay, that's the inside function, into f of x. So g of x is x squared, so we're going to put this g of x into here. And remember what we're doing, just like last time when we did function notation, we are replacing x, in this case, with g of x. Okay, so f of g of x is going to equal to, so again, the outside function is f, so I'm going to start with my f, which is 2x plus 3. Now I see 2, so I'm going to write down 2, but now I see x. So what that means is I'm going to put g of x into x instead. I know that g of x is x squared, so this becomes 2 times x squared, and then plus 3. Notice how this was an x, and now it's being replaced by g of x, which is x squared. So then this is just simply 2x squared plus 3. Okay, so that's what f of g is. Part B says, well, is this the same as g of f of x? So if we switch f and make it become the inside function and make the g become the outer function, are they going to have the same result? Well, let's take a look. Okay, so this, we're looking at g of f of x. So again, what this means is we're going to put f into g of x. So I'm going to start with g of x first. But when I look at g of x, it's just x squared. So instead of putting x squared, I'm going to replace that x with f of x, right? Because you can see x is being replaced by f of x. And f of x is 2x plus 3. Okay, so that's what g of f is. We can expand this. You should get 4x squared plus 12x plus 9. And you can see they are completely different. Okay, they have nothing to do with each other. Okay, so g of f and f of g are different. Of course, sometimes they could be the same. Very unlikely, but yeah, it's possible, I suppose. But again, very unlikely. Okay, so that's what it means by composite function. Basically, you have an inside function and you have an outer function. And of course, composite function does not just mean two of them, right? It could be 3 functions. You can definitely have f of g of h, right? You could have 3 functions. You could have 4, and so on and so on. Okay. You're just adding more layers to it. Okay. So that's what it looks like. Well, that's what composite function looks like in terms of the functions. But of course, functions could be defined by looking at the tables, right? So here are 2 functions. Here's the f of x right here. Right? Here's the f of x table, and here's the g of x table. We can actually figure out even though we don't know what the function is, we don't actually have an algebraic expression for f of x and g of x, but we can again be shown the function by the table here, and we can actually figure out what these values are going to be. Okay, so part A says, what is f of g of -1? So what this means is we actually need to figure out, again, inside function first. The inside function is g, so we have to look at the table on the right first, g of -1. So when x is -1, g of -1 is going to be 2. So this f of g of -1 becomes f of 2, because g of -1 is 2. And then this is simply just a function notation. We can find f of 2 quite easily by looking at the table on the left. So f of 2, so when x is 2, f is going to equal to 1, and that's the answer. Okay. Part B, you could also have a function inside itself, right? So we could have f of 1. So same thing, what we need to do first is to figure out what the inside function tells us, which is f of 1. So f of 1 is going to be f of 1, when x is 1, f is -2, so this becomes f of -2, and f of -2 is simply going to be 5, right? So that's what it means. When x is -2, the y value, f of -2, is going to be 5. Okay, so here are 2 practice questions for you to try. Good luck. Alright, so hopefully these are the answers that you got. Again, g of f of 2 means you got to figure f of 2 first, which is 1. And then once you have that figured out, then you can just simply find g of 1, which is 0. Second one, again, g of g, you have g inside the function itself. So first you find g of 2 first, which is -2. Then you can figure out what g of -2 is, which is 5, and that will be your final answer, okay? So here's the algebraic expression for example number 1. Example number 2, we look at the tables. Example number 3, now we can again, functions can be represented in different ways, right? Algebraic expression, table of values, or it could be graph. So let's look at this, these 2 graphs, f and g, and then let's figure out these values here. Okay, so first one, f of g of -2. So the green graph is f of x, and the blue graph is g function. So first, again, you always look for the inside function first. So the first example, we need to figure out what g of -2 is. So with the blue function, or the g of x, what is g of -2? Well, g of -2 simply means what's the y value when x is -2 for the g function. So when x is -2, the y value is actually 8. So this f of g of -2 becomes f of 8, because g of -2 is right here, which is 8. Okay, and now we can look at f of 8. So when x is 8, the y value for the f function is going to be 3. So that's this point right here. So this equals to 3. Okay. Similarly, with g of f of 3, the first step we need to figure out is what's f of 3. So this is going to be, let's see. So f of 3, so f is the green graph again. So when x is 3, the y value for f is 2. So this is g of 2. And then g of 2 for the blue graph, g of 2 is right here, which has the y value of 0. So g of 2 is 0. Okay, so same thing. Give it a try. See how you do. Alright, so for these 2 questions, again, you got to work inside out. So you got to find the inside function first, which for the first one is g of 2. And g of 2 is right here, has the y value of 0. So f of 0 is 1. That's right here. For the second practice question, you have, again, inside out. So you got to figure out f of -1 first. So f of -1 is right here, has the y value of 0. So it becomes g of 0. And g of 0 is right here, and it has a y value of 4. So that's your final answer. Okay. Example number 4. So now we have, again, algebraic expression. In the first example, we were just looking for what g of f of x. So we're looking for the function, but now we're searching for the value. So we can do this quite easily. Again, same thing, you got to work inside out, right? So you're looking for g of -2. So what you got to do first is to figure out what g of -2 is by plugging -2 into x in the g function. So this is going to be, so I guess I'm going to do it separately here. I'm going to find g of -2 first. This is going to be 1 over -2 squared minus 1. Okay, So this is going to be 1 over 4 minus 1, which is 1/3. Okay, so g of -2 is 1 over 3. And now we found what g of -2 is, so then we can plug this into the f function, and we can look for f of 1 over 3. And now we simply put 1 over 3 into the x that we see in the f function. 1/3 plus 2 is 2 and 1/3, which is 7 over 3. And of course, the absolute value of positive value is still positive, so your answer will be positive 7 over 3. Okay, part B, similarly, now we're going to work inside out. So in this case, we're going to start with the f function. So I'm going to work with f of -5 first. And again, that means plugging -5 into x in the f function. So that's -5 plus 2, which is -3. And we know the absolute value of -3 is going to be positive 3, because again, absolute value symbol makes everything positive. So now our question then becomes, what's g of 3 then? So then, same thing, I can then plug in 3 into x in the g function, and then I can evaluate. 3 squared is 9, so 1 over 8, and that will be your final answer. Okay, there's your 2 practice questions. Good luck. Alright, so for these practice questions, hopefully these are the answers that you got. Again, you got to work inside out, so you got to figure out g of 4 first, which you get 7. And that just becomes f of 7, which is 30 right there. For the second one, same thing, inside out. So you got to figure out f of 5 first, and you should get 12 out of that. And then the question becomes, what's g of 12? And then if you plug in 12 into x, you should get 23. Okay, as you can see, composite function is actually not that bad, right? It's actually quite straightforward. Just got to make sure that you work inside out. Okay, you have the inside function, so do that first, and then apply to the outside function. All right, example number 5. So given that f of x is x squared minus 3x and g of x is 2x plus 3, we want to figure out the explicit equation for each composite function and then state its domain and range, if possible, okay? So, part A, so basically this is what we did in example 1, but now we also want to figure out the domain and range, right? So, nothing new, really, but because there's no value here for x, so we don't actually try to figure out g of something is, right? Because we can't. We just know that g of x is 2x plus 3. Again, what this means is basically we're going to put g of x inside of f of x. Okay, so I'm going to start with f of x, which is x squared minus 3x. But again, anytime I see x, I need to replace x with g function, which is 2x plus 3. So it's going to be 2x plus 3 squared minus 3 times 2x plus 3. Okay, notice how if you look at the overall structure, it's f of x. It's just that we're replacing x with g of x. Okay, and so now we can expand this. You should get 4x squared plus 12x plus 9 minus 6x, and then minus 9. Okay, minus 6x and then minus 9, in which you should get 4x squared plus 6x, and that's it. Okay, so this is your f of g. And then we need to state the domain and range. Now this is a quadratic function, so recall domain for quadratic function would be all real numbers. For range, this is a little bit trickier. We need to find the vertex. And hopefully you know how to find the vertex of a quadratic formula or of a quadratic function. You can either complete the square, or again, I might have shown you this. I can't remember anymore. You can find the x-coordinate of the vertex by simply x-coordinate by simply using the formula that x is going to equal to negative b over 2a. Okay, this is basically the part of the quadratic formula. Okay, if you look at the full quadratic formula, there's the plus minus square root and blah blah blah. But we don't need that. The x-coordinate of the vertex is simply going to be negative b divided by 2a. So in this case, b, recall the values of a and b's would be the coefficient of the x squared term, that's a, right? This is a, and the coefficient of the x term, that's b. So it's going to be negative 6 divided by 2 times a, which is 4. So this is negative 3 over 4. Okay, so that's the x-coordinate. And of course, we can find a y-coordinate by simply plug in the x-coordinate into the equation. So we have 4 times negative 3 over 4 squared. Whoa, what happened there? Plus 6. Okay, you can see the pen is not working very well, unfortunately. 6 times negative 3 over 4. So if you put this into a calculator, or if you just expand this, I have this worked out already, that you should get 4 over, oh my gosh. Okay, 4, oh, wow. Okay, timeout. Of course, when I'm not recording, it works out just fine, right? Oh, here we go again. But when I'm recording, then it doesn't work as well. Okay, 9 over, it actually get negative 9 over 4. Okay, that would be your final answer for your y coordinate. Okay, so your range, because this is a positive function, I mean not positive, but leading coefficient is positive, therefore this this parabola opens up, and therefore our y coordinate will be the minimum value. So your range is going to be y is going to be bigger than or equal to, okay, timeout again. Okay, so your range is going to be y is greater than or equal to negative 9 over 4, because that's the minimum. Okay, so there's your domain and range. Okay, I'm going to use a different color for the next question here. All right, so for g of f. So same thing, I'm going to put the function inside function f into the outside function g. So this is going to be starting with the g function, right? So that's 2 times x. So now when I see x, I'm going to put the function f inside, and then plus 3 at the end. So you should end up with 2x squared minus 6x plus 3. Okay, so this is your function. And now we can find the domain quite easily, again, because it's a quadratic function, so the domain is going to be all real numbers. However, for range, it's going to be slightly trickier because we need to find the vertex. Recall, the x-coordinate is going to be negative b divided by 2a. So it's going to be negative of negative 6 divided by 2 times 2, which is going to be 3 over 2. Okay. To find a y value, you simply plug in 3 over 2 into the function. So 2 times 3 over 2 squared minus 6 times 3 over 2 plus 3. Again, I have this worked out already, so you should get negative 1.5. Okay, so the range is going to be y. Again, this is a minimum because, again, the leading coefficient is positive, so the graph opens up. So we have a minimum of negative 1.5, therefore the range is going to be y is greater than or equal to negative 1.5. Okay, one thing I also need to mention is that because you can see these two examples, or in this example, right, but two questions here, the function f and function g, these two functions, they all have all real numbers for their domain, and therefore our composite function would also be all real numbers. Okay, the domain would also be all real numbers. If there's a restriction for either f or g, then you got to be careful. Okay, then you got to be careful. Okay, because let's say we have f of g of x, right, and let's say g of x is, let's say, square root of x, and then so let's say this is g of x, and let's say f of x is x squared. Okay, so then if you do f of g, right, in that case f of g of x, this is going to be square root of x squared, which is going to be x. So if you just look at this, you might think, okay, well, in that case, I guess the domain is all real numbers. No, it's not, okay, because of this. In this case, the domain would be x has to be greater than or equal to 0. Right? If x is not bigger than or equal to 0, you can't do this. And if you can't do g of x, well, there's no f of g because, right, g of x is invalid. Well, then how can you do f of g? Okay, so you got to be careful when f and or g, the domain is not all real numbers, then you got to be careful with your domain for your composite function. Okay, so it's not just what you see at the end, right? It's not just the end result that you see, okay? Because you got to watch out for the original function f and g as well. Okay. Anyways, in the practice, these both of these functions are still all real numbers for the domain, so there's no problem with the composite functions. So I'll let you try these three, and yeah, good luck. Okay, so for the first one, this is what you get, f of g. So you put g into f, and that's what you get. Again, it's a quadratic function. Domain is all real numbers, and range is going to be bigger than or equal to 1 because I found my vertex to be 1/2 comma -1. And again, this parabola opens upwards. Okay, for part B, g of f, we are going to put f into g. So I'll do it quickly here. So it's going to be -2 times x, which is the function f, which is going to be 2x squared minus 3. Plus 1 here, so you should get -4x squared plus 6 plus 1, so plus 7. Again, it's a parabola, so domain is all real numbers. For the range, we can use the formula again, but I mean, this one I know the vertex already, but it's okay, I'll show you. It's going to be -0, because the value b is 0, right, because there's no b term here, or there's no middle term here, times 2 times a, which is going to be 0. Therefore, the y value is simply putting 0 into x, which is going to be 7. This time, the leading coefficient is negative. Therefore, the parabola opens downwards. So we actually have a maximum. And therefore, y should be less than or equal to 7 in this case. Okay. Finally, we're going to put g into itself. So this is going to be -2 times the g function, which is -2x plus 1. And then plus 1. This is going to be 4x minus 1. This is a linear function, so that's easy. Domain is all real numbers. Range is also all real numbers. Okay, so I don't think this is too difficult. It's actually pretty straightforward. But again, if you have, I think the only difficult part might be figuring out domain and range, especially when f and g, the domain for those two functions are not all real numbers. Then it makes it a little bit more complicated for the domain for the composite function. Okay, but anyways, do your practice questions. Let me know if you need some help. Otherwise, good luck. Okay, see ya.